Hi everyone. From today, we will learn all kinds of entities. So we have seen how to represent entity and also how to represent the relationship. So from now on, we will study all kinds of entity and the relationship one by one. So the first case of entity is ID dependent entities. Okay, so there may be many kind of entities, but the first entity type is ID dependent entity. So this ID represent identifier. Okay, so that means that one entity will depend on the other entity's identifier. Okay, so an entity whose identifier include identifier of another entity, that is ID dependent entities. So this ID dependent entity will be a logical extension or subunit of parent. Okay, the example of ID dependent entity is here, building and apartment. So the building is here. The building number in my case is 207. And this building has many apartments, 1, 2, 3, and 17 floors. Okay, so many apartments exist in these buildings. So among them, this building number is 602. Okay, so in order to identify this 602, we need building number 207. Okay, so this building is this one, and apartment is individual apartment. So in order to identify this apartment, we need this building number. In this situation, this apartment is ID dependent entity. Can you understand? Yes. So this apartment entity cannot exist by itself. So in order to exist apartment, they need necessarily building entities. So this apartment will depend on the building. So this apartment is called ID dependent entities. The same way, painting and print, just like Mona Lisa in Louvre Museum, painting is original, genuine Mona Lisa paintings. And there may be many prints or copy of these paintings. In that case, this print is ID dependent entity of paintings. Okay, so in order to exist ID dependent entity, there must parent entities. So this original one is parent entities, and this ID dependent entity is called child entities. So this right part is child, and the left part is parent. Okay, so minimum cardinality from the ID dependent entity to the parent is always 1. Always 1. Okay, so that means that there always exists the parent. Okay, yes. So we can see the examples of these ID dependent entities. So building and apartment. Yes. So apartment is individual house, individual home in the whole buildings. So building has building name 207. And apartment is apartment number. My case is 603. So in order to identify apartment number, we need building number here. So in that case, this apartment entity is called ID dependent entity. So in order to represent that this is ID dependent entity, we must use this one. So solid line. This solid line means that it is ID dependent entity. And also parent must be 1, maximum cardinality 1. And minimum cardinality is mandatory here. But in the ID dependent entity side, it may be multiple maximum cardinality, and it may be optional in minimum cardinality. Okay, the same way painting and the print also applies ID dependent entity. Print is ID dependent entity. So in order to identify print, we need a painting name Mona Lisa, and the copy number is 6, 7 like that, etc. So we can represent this ID dependent entity using solid line, and this is 1 maximum cardinality and mandatory maximum minimum cardinality. And the ID dependent entity has many maximum cardinality and optional minimum cardinality. How about patient and exam? So there may be some examination number there. In order to identify examination number, we need a patient name here. So they include identifier of a parent. This upper is parent, this lower is child. Okay, so all ID dependent entity can be represented using solid line, and this parent side there must be 1 in maximum cardinality and the mandatory in minimum cardinality. That is the same rules in ID dependent entity representation. Okay, this was example. And second entity type is weak entity. Weak entity. So weak entity is another type of entity in ER diagrams. So weak entity is entity whose existence depends on another entities. Okay. Yes, it's a very similar concept to the ID dependent entity. So this weak entity existence depends on the other entities. So all ID dependent entity, first entity type was considered weak. Yes, every ID dependent entity also called as weak entity. But there may be non-ID dependent weak entity can exist. Okay, So identifier of the parent does not appear in the identifier of a weak child entity. Yes. Also, there is no ID of a parent in child. The weak entity cannot exist without the other entities. That entity is called weak entities. So of course, if we consider Venn diagram, this is a ID dependent entity set, and this is a weak entity. In that case, every weak entity, every ID dependent entity is a weak entity, but not all weak entity is ID dependent entity. So we can say it's a subset. ID dependent entity is subset of weak entities. Okay? Yes. So that's the weak entity types. So we can go on. Comparison of ID dependent entity and non-ID dependent weak entities. Yes. So auto model. Auto model is, my auto model is Sonata. Okay. And the vehicle means that individual instance of this auto model Sonata. My vehicle is and the plate number is 8865. Okay, in order to represent this vehicle 8865, my car, we can include manufacturer Hyundai and the model is Sonata. Hyundai and Sonata is here, but manufacturing sequential number is 8865. Okay, so if we design automobile ER diagram like this one, auto model and vehicle entity, then and also we design attribute as manufacturer, model, manufacturing sequence number, just like a vehicle here, then this vehicle is ID dependent entity because manufacturer exists in the parent, model exists in the parent. Okay, vehicle identifier include the other parent entities attribute identifier. Then this is ID dependent entities. So we can represent this relationship as a solid line. Can you see this is a solid line? And also minimum cardinality, maximum cardinality. Minimum cardinality is compulsory and maximum cardinality is only 1. And ID dependent entity side is many, and also minimum cardinality can be optional here. But if we modify this ID dependent entity slightly to the right one, this is also vehicle entity, but they use is a VIN number, vehicle identifier number. It's a surrogate key in chapter 2 terminology. VIN number, VIN, is a very common word in America to identify each vehicle's VIN number. This VIN number is artificial primary key, surrogate key. Okay, so if we design a vehicle like this one, in that case, this is not ID dependent entity. No ID dependent entity. This is no ID dependent because the identifier do not include the parent's identifier. Okay, so we can represent this relationship as dotted line. Can you see the dotted line here? Yes. And also the maximum cardinality, minimum cardinality is the same in each side here, but dotted line. So we can see that only ID dependent entity uses solid line. This is a solid line. Okay, the line type is different. So left one is a solid line, and the right one, non-ID dependent entity, is dotted line. So weak entity, but this is a still weak entity because vehicle cannot exist without automodel entities. Okay, so we can see that there is weak entity that is not ID dependent entity. This is the count example of that one. Okay, yes, this is weak entity, and we can compare ID dependent entity and weak entity. Even though they are very similar concept, there is also clear difference. So weak entity is an entity whose existence depends on the other entity. And ID dependent entity is a weak entity. It's a kind of a weak entity. But its identifier include the identifier of a parent entity. Okay, so that's the difference, this one. And identifying relationship. Yes, in order to represent ID dependent entity, we must use identifying relationship. Identifying relationship means that solid line. Okay, solid line represent identifying relationship. The other weak entity, non-ID dependent entity, relationship is a dotted line. Some entities are weak but not ID dependent. Using data modeling tools, they are shown with a non-identifying relationship is a dotted line. Okay, dotted line. So all ID dependent entities are weak entity, but the reverse is not true. Okay, so we can draw ID dependent entity, and the superset is weak entity. Okay, so ID dependent entity is a subset of a weak entity set. Okay, and now third types of entity is subtype entities. So subtype entity is a special case of supertype entity. Okay, so there is a student entity and undergraduate entity and graduate entity. So undergraduate entity is subtype of a student entities. Okay, so supertype contains all common attribute, while subtype contains only specific attribute. The supertype may have a discriminator attribute which indicates the subtype. Okay, you can see the example here. Student entity is here. It's a supertype. And this is a subtype, undergraduate and graduate entities. So this undergraduate entity is a subtype means that they include all of the supertypes attribute like student ID and last name, first name also included in the subtype. Okay, and this is a graduate student is a flag field. This flag field will be a discriminate flag. Discriminate between undergraduate and the graduate entities. Also, this subtype entity has two types. One is exclusive or the other one is inclusive. Exclusive has one supertype related to at most one subtype. And the inclusive is one supertype can relate one or more subtypes. So they are different. So to represent exclusive, we use these symbols, X symbols. And inclusive, this no X symbols in discriminator, in flag. So this student can belong to hiking class, hiking club, or sailing club. Okay, so we can belong to either or both of the entities. So this is an inclusive subtype. And this subtype has its own names, is a relationship. So this is a name of subtypes. Okay, among the several relationship type, only two relationship has their own name. This subtype has one own name. The name is a relationship, and also 1 to n relationship is called has a relationship. Can you remember that? Yes, you must memorize two relationship type which has names, its own names, is a relationship and has a relationship. So subtype is a supertype. So this is called is a relationship. This subtype can be used to avoid value inappropriate nulls. So there is some cases that null is not appropriate. In that case, we can utilize this subtype entities. And examples of this one is here, and also this one, next one is summary of all ER diagram symbols. Okay, so every entity can be represented using rectangles. Okay, rectangle, this entity name, and identifier has a top area and the bottom area, etc. attribute. And this is entity definition, and after that you can represent every relationship types. So one-to-one non-identifying relationship is dotted line, and the one-to-one can be represented in here, maximum cardinality and the minimum cardinality. Non-identifying means that dotted line, and the 1 to n non-identifying is a 1 to n maximum cardinality, and the dotted line means the non-identifying. And many to many, n to m, non-identifying dotted line. And the opposite of non-identifying is identifying. ID dependent entity will be represented as solid line. This is a solid line. Can you see that? Solid line. And 1 to n. 1 to n. So that means that B entity must include identifier of A. That is ID dependent relationship. Okay. And also there may be some supertype and subtype. A is a supertype, C and D are exclusive supertype. Exclusive supertype means this X. And last one is A is a supertype still, but C and D are inclusive subtype. Okay. Yes, it's a summary of all symbols in information engineering ER diagram symbols. Okay, now so fourth Now go to fourth entity types. Fourth entity type is a strong entity. We have learned what is a weak entity, but this is a strong entity. Of course, a strong entity means that they can exist by itself without depending on any other entities. Okay, so this shows some example of a strong entity. If we are given this user interface, UI, graphic user interface. Graphic user interface has club membership data entry forms. So club member locker, club member number, member name, phone, email, locker number, locker room. Okay, so if you are given this user interface, then what kind of entity are there? Can you guess it? So we can extract entity from this user interface, like a member entity and a locker entities. Okay, so two entity may be extracted from this user interface. And a second example is club locker report. Also has member name, locker number, locker room, locker size. Locker size has added here from locker room, locker size. Okay, so in order to represent both of this user interface, okay, two entity can be retrieved from this user interface. So the next one, this club member entity and the locker entities, they have attribute member number, member name, phone, email, and the locker also has locker number, locker room, locker size. Yes, in order, because of the report, this locker size is added. In here, the relationship between club member and locker is non-ID dependent entity. Non-ID dependent entities, because the other entity identifier is not included in each in any entities, so it's a non-ID. That means that the relationship type is a non-identifying relationship, dotted line first, and then maximum cardinality 1 to 1, and minimum cardinality optional to optional. Okay, and especially you have to decide that they can exist by itself. So locker can exist by itself without existence of club member. Yes, then this locker is strong entity. Strong. Okay, so this dotted line means that they cannot distinguish weak entity or strong entity, but strong entity must decided based on the decision of your design. So locker can exist by itself or not. If it is a yes, it is a strong. If not, it is a weak entity. Okay. Also, club member can exist by itself without depending on locker. Yes, it's a strong also. Strong. Okay. So club member entity is also strong entity, and the locker is also strong entities. Okay. That's the one-to-one cases, and this is also strong entity, but relationship maximum cardinality is 1 to n cases. So this user interface, graphic user interface, or it is called user requirement, is the company name and city and department in this company. So Ajax Manufacturing is in Sydney, and they have 1, 2, 3, 4 department. So department name, budget code, and mail staffs. Okay, so this is a graphic user interface, or it is called user requirement. User requirement. Okay, so in order to satisfy this user requirement, we must develop ER diagrams. So what kind of entity is necessary for this user interface? So company and department, 2 entities can be retrieved. So we can define the attribute of each entity, and also we can define relationship type. Okay, so next page, this is 2 entities, company and the department. Okay, and also company name, city, and department has a department name, budget code, mail staff. The relationship, this is entity, 2 entities, and relationship is not non-ID dependent entity, because the ID of the other entity does not exist here. So it is non-ID dependent. So we can say that it is a non-ID dependent relationship, non-identifying relationship. So it's in other words, it is a dotted line. But we do not know if the relationship is a weak entity or a strong entity. So we must ask these questions. Department can exist. Can department exist by itself or not? If yes, it is strong. If it is no, it is weak. No, it is weak. What is the answer? Department can exist by itself without depending on company? Yes. Then this department entity is strong entity. And company, also the same question can be asked, can be applied to the company. So can company exist by itself without depending on department? Yes. So also company is a strong entity. Okay, so in this way you can decide every component in ER diagram, entity and relationship and entity types also. In this way you can elaborate ER diagram one by one. Okay, the next example is also strong entity, but it is an N2M relationship type. So the user requirement or graphic user interface is supplier form and the part report. In order to satisfy this supplier's form and the part report, we can what kind of entities are necessary, and what kind of relationship between them. So here company name and the parts. Yes, one company can supply many parts. In this case, 3 parts. And each part can be supplied by many company also. Here, Bristol, ELS, Forrester supplier company can supply this cedar shake to our company. Okay, so you can see that the types of entity necessary is here, company and parts. So the relationship between them is end-to-end. One supplier can supply many parts. One part can be supplied from many suppliers. So we can decide that maximum cardinality end-to-end. And also, here, end-to-end relationship is here, company and part. So end-to-end, many-to-many is here. And how about minimum cardinality? For part, the supplier company must exist. One company, one supplier company may not have no part to supply. Okay, so some company maybe non-supplier company, like a bank is also one company of our company. So no parts may be possible. So minimum cardinality of a part is optional here. And also non-ID identifying relationship between these two entities, and also weak or strong. They can exist by itself. Part exists by itself, and the company can exist by itself. Strong. And before that, we have seen relationship between company and department. Okay, in this way, we can develop ER diagram one by one. So we can extend one by one. So if there are many user requirements, in order to satisfy all of the user requirements, we need many entities. And also, we must define many relationship between many entities. So that's the result of ER diagram development. Okay, this is a most complex end-to-end strong entity relationship. Okay, go on next one. Okay, now the other part is kind of examples. So this one is ID dependent relationship. Yes, another cases. Yes, I think it is called fifth cases. So ID dependent entity examples, special examples. So in here, association patterns. So if there are two entities relationship and the special relationship has its own names, this association relationship. Okay, this association pattern relationship may happen from this user interface. Part quotations. Yeah, quotation means that price suggested by a supplier company to our company. Okay, so this columns price is added to the previous user interface. Okay, so we have seen part report in the previous examples, but in this user interface or report has one more columns, price columns. Okay, so this part 1000 may be supplied from Bristol system with 14 US dollars price. Okay, if this report is user requirement, then how we can association patterns. So this quotation user interface can be extracted to one entity, quotation entities. Okay, so because we have seen that part and the company relationship was many to many. So this many to many relationship is transformed to the two, one to many, okay, two, one to many relationship. But instead of that, we need additional entities. This entity is quotation entity, but this quotation entity has two identifier: part number, company name. Part number, company name. Yes, this part number is identifier of the other entity. Company name is identifier of the other entity. So that means that this quotation is ID dependent entities. Okay, so this is ID dependent entity. Okay, and so this types of entity is necessary to transform N to M relations to 1 to M relationship. Okay, so this is this special purpose entity is called association entity. Okay, so by using association entity, we can change N to M relationship into 1 to N relationship. Okay, in this way. But especially this quotation entity has additional attribute, price attribute here. Okay, this kind of entity which has additional attribute is called association entity. But how about if there is no additional attribute here, just like price? So that means that they have only two identifier in. Okay, so we can learn another relationship as in later chapters without additional attribute, but this is a association pattern. Association entity means that they have a additional attribute here. Okay, and I will skip this multi-valued attribute here, and multi-value attribute pattern. This is one example, so you can learn or skip. Composite multi-value attribute can be skipped. And The other one is ID dependent relationship pattern is archetype and instance. Archetype is template and instance patterns. So this was learned at the ID dependent entity. Okay, so when ID dependent child entity is physical manifestation of logical parent. Okay, so as we seen painting and Mona Lisa and print copy and class and sections, house, model, and the house. They are all archetype and instance patterns. So they are all identifying relationship. Yes, here this is a solid line, solid line, solid line. That means that identifying relationship because class name is included here. So that means that section is ID dependent entity. And the yacht is also ID dependent entity. House is ID dependent entity. Okay. But if you change the design as non-ID dependent entity, then this becomes non-identifying. That means the dotted line here, dotted line here, dotted line here. So these are not ID dependent entity, but house, yacht, and the sections are all weak entity. That means that they cannot exist by itself. And last pattern is line item patterns. So this is a very related with Cape Cod database. In Cape Cod database, we use the order item and retail order and also SKU data. Okay, so all of them, order item, especially order item, they have line items, order item. Table in Cape Cod DB, they have a line item in these tables. So this sales order number has 4 items. This one first item is called one line item, 2 line item, 3 line item, 4 line item. Yes, there are 4 line item in this sales orders. In this case, how can you design this user interface? Okay, so this one, oh, there are many. 1, 2, 3, 4, 5. 5 entities are extracted from the previous user interface. So you can customer, sales order, order line item, and sales persons. So in Cape Cod database, we have 3. This is a retail order. And this is a order item. And this was SKU. Yes, that was Cape Cod DB. In addition to this Cape Cod DB, they have a customer, they have a salesperson here. I think this customer is a buyer in Cape Cod DB. So this customer. Okay, this is important example. So other mixed pattern exists here, so we can skip this one and skip this one. Recursive relation, skip. So, and the last big example is Highline University. Okay, this is a university database. So you can follow all of this example. From this first data model, start with 2 entities, college and department. And in order to satisfy this user requirement, department depot, we added department entity here. And also we can change a little bit professor here. So, and this is a new report, department student report. So we must add a student entity here. So by in this way you can extend the first model one by one, second model, third model, and there is a acceptance letter here. So we need this one. I think fourth data model and the final model is here. So to represent one university database, we need this kind of final data model. Okay, that's all for today's class. So this is the end of chapter 5. Okay, thank you.